Selecting features is one of the core functions of a GIS. You may only be interested in a subset of a data layer. When you select spatial features, the corresponding records in the attribute table are also selected and vice versa. Any GIS operation can be run on just the selected set of records or features. For example, if you have counties of the US and you select those in Vermont, you can save the selected features or records as a new GIS layer. Any GIS operation can be run on just the selected set. Selections can be done interactively by using expressions to query the attributes of a layer, or spatially. Here you'll see all three methods. So here I have QGIS Desktop open with the QGIS map document from Lab 4 Task 2 open. I've turned on neighborhood diabetes, and I'll turn off the fast food heat map. First, let's explore interactive selection. I'll select the neighborhood diabetes layer in the Layers panel. Then I'll click on the Select Features by Area or Single Click button. There's a drop-down tool menu that provides several ways to select features interactively. I'll choose Select Features and click on a feature on the map, and it'll be highlighted in yellow. Now I'll open the attribute table for this layer. You'll see that the corresponding record is also selected. Whenever you have a selected set of records, you can use the Show All Features drop-down menu in the lower left corner to show only the selected records. There are several other options available on this menu. I'll click on Show Selected Features, and now I'll see just the selected records. Now I'll close the attribute table. This Select Features tool can also be used to select multiple features. Using the tool, I'll click and drag a box with my left mouse button across a portion of the city. All the polygons I interacted with are now selected. To unselect these features, I'll click the Deselect Records from All Layers button. Now I'll explore attribute queries using the Select by Expression tool to select neighborhoods with high poverty rates. I'll open the Neighborhood Diabetes attribute table. In addition to the diabetes data I joined to this table, there are a lot of columns of socioeconomic data. I'll click the Select Features using an Expression button to open up the Select by Expression window. So let's get oriented. On the left-hand side of the window is where I'll form my SQL expression. In the middle are available functions. On the right is a context window that provides help and sample field values. Across the top are some commonly used operators. To start my query, I'll expand the Fields and Values section. The attribute columns in this layer are listed. I'll select the Poverty field. The right window now splits into Help and Values windows. I'll click the All Unique button, and QGIS will scan the column and print all the unique values in the poverty column for this layer. These represent the poverty rates. To form my expression, I'll double-click on Poverty to add it to my expression window. Then I'll scroll down the list of functions and expand the Operators section. I'll double-click the greater than operator to add it to my expression area. I'll scroll back up and reselect the Fields and Values Poverty column. To complete my expression, I can use one of these values from this column, or I can type a numeric value into the expression window. I'll double-click on 20 to finish my expression. With my expression complete, I'll click the Select button. 117 neighborhoods match my query. They're both selected on the map and in the attribute table. Another useful technique is feature selection by location. This allows you to select features in one layer that intersect or touch features in another layer. I'll click the Deselect All to clear my selection and close my attribute table. I'll use the Select by Location tool to identify neighborhoods with a fast food restaurant. I'll click the Vector menu, scroll down to Research Tools, and choose Select by Location. The layer to select from is going to be Neighborhood Diabetes, and the additional layer will be Baltimore Fast Food. There are several geometric predicates to choose from. Here I'll choose Intersects. I'll leave Modify Current Selection by creating New Selection, and I'll click Run. The neighborhood polygons that intersect a fast food restaurant point are now selected in yellow. I'll open the attribute table for Neighborhood Diabetes. There are 271 records in the table, meaning there's 271 neighborhoods in Baltimore City. Of those, 85 are now selected, meaning they have a fast food restaurant. I'll scroll to the right side of the table where the Baltimore City D column is. This is the column that contains the number of people diagnosed with diabetes. Remember, I joined this column to the neighborhoods layer in Lab 3 Task 2. I'll click the column header to sort the data based on these diabetes values. I'll scroll up and down and observe the values. Notice that the majority of neighborhoods with high diabetes totals are selected. I'll close the table. Now I'll explore these data a bit more using the Show Statistical Summary button. This opens the Statistics panel. I'll select Neighborhood Diabetes as the layer and Baltimore City D as the column, and then choose Selected Features Only. Basic statistics on the number of diabetics in the selected neighborhoods are now displayed in the main window. This shows that 40,433 diabetics live in those neighborhoods with easy fast food access. Next, I'll uncheck Selected Features Only so that it's showing statistics for the entire layer. This shows that there's a total of 82,831 diabetics living in Baltimore City. And you now know that of those, almost 50% are within neighborhoods with easy fast food access. So using the GIS, you've gained some valuable insights into this data set. I'll close the basic statistics window, and in the next task, you'll learn how to calculate areas and densities.